Okay, here's another compressor question. The question states, a carbon dioxide compressor receives vapor at a rate of 140 pound-mass per hour. The enthalpy values at the inlet and the outlet are 139 and 216 respectively. The compressor shaft power is 5 horsepower. Under these conditions, the straight heat transfer to ambient from the compressor is most nearly what? So first we'll start out by drawing a diagram. So we have our shaft, we have a compressor, and we know that the work on the shaft is 5 horsepower. We also know the inlet conditions to the compressor and then the outlet conditions. So the mass flow rate we know is 140 pound-mass per hour. And we also know the entering enthalpy, which is this 139. And we also know the exiting enthalpy, which is 216. And we can draw a control volume for this guy. We can also know there is straight heat transfer. So we know that there's some kind of heat leaving this system, so Q. And this is essentially an application of the first law of thermodynamics. So we have our U equals Q minus W. Well, this U, this internal energy, isn't changing. So this guy will go to 0. And then we're just left with Q equals W. Okay. So we basically have two W's. We have the W from the shaft, and then the W from the refrigerant. So I'm going to kind of break this up. So we have W1 equals 5 horsepower. That's this guy coming in. And we have W2 equals m dot delta H, or 140 times 216 minus 139. Okay, so this question asks us for straight heat transfer in terms of BTUH. But we have 5 horsepower here, so we're going to need to convert this guy into BTUH. So if we go to our handbook, and we'll need to grab the conversion factor. So this guy here, plus that. So we will need to divide this guy by 3.930 e to the minus 4 1 BTUH. So I'm going to put that in my calculator real quick. And that gives us 12,722 BTUH. And then I'm going to get this W2. So 140 times 216 minus 139. That gives us 10,780 BTUH. So we're going to plug both these guys into this W here. So we get Q equals W, which is also 12,722 in, minus W2, which is 10,780. Get my calculator. 722 minus 10,780. This gives us 1,942 BTUH. So this is our Q. This is the heat that this system generates. And this is due to really the inefficiencies of the system. If this was perfectly efficient, then your W2 would equal your W1 essentially. But since it's not, we have some kind of heat that's generated. So our answer in this case is D.